ASTRO. So in this Photutils Python tutorial, you are going to learn that how to extract your radial flux profile of any star or galaxy or any object from the FITS file image. So flux density is basically your say flux divided by your area in that annual region, and you have to plot it on uh, a scale of your y equal to say flux density and x equal to radius. So a typical radial flux profile may look like this. Okay, this is a typical flux profile. And now, so let's do it. Okay, so in my earlier videos you have seen that we have plotted circular aperture around an object, and we have got its curve of growth. So this time we are going to obtain that how flux in each region is varies with distance. Okay, so we have say from center to outward how much flux is there. So let's do it. So for doing that, we have flux density in the circle of I plus 1 to I equal to flux divided by pi r square minus pi ri square, means the area of successive radius minus previous area. So for doing that, we have to proceed as follows. So we have radius. Okay, so radius we have this one. I can print it. So this we have radius. Now we have to find this pi r I plus square minus r square. So you can make it, you can call it r square and then rad square. So this becomes your radius square, and now you want to make the difference of these from each other. So type here r difference variable and then give np dot diff r square. So basically this will give so this will give the radius of successive and minus previous. So basically 2 minus 1, 4 minus 1 equal to 3, then 9 minus 4 equal to 5. Okay, so this you got. Now you need to also add the first one. Okay, because like one is like missing from this array, and because also the length, if you check it, then length becomes 19, but you have like 20 apertures. Okay, so what you will do, you will type here area equal to, or maybe you can type n equal to np dot append 1 and then rest of radius. So d dot difference. Then if you type n, so n becomes 135 and then it goes to 39. So now the length is 20. Okay, so now you find the area. Okay, the area of annular regions equal to you give, or maybe you can simply yeah, so simply you can put here flux density equal to flux divided by 3.14 into your n into n. So this becomes, now you need to plot it. So now plot radial flux density profile. Or simply called flux profile. Now, okay, so type here PLT dot scatter, then give your, say, your radius, and then you can give your, say, flux density, and then you can give your PLT dot figure, and then here PLT dot show. So this is for plotting radial flux profile. Now run it. So if you run it, you will get this kind of shape. Okay, you can also make it line plot if you want. PLT dot plot and give the same argument of x and y. So this you got your flux profile. Okay, so this way you can do the profile of a star, that how flux varies with your radius. Now you can give label. So PLT dot, so we have a title, so just give here, copy from here and paste it. So this time your flux is y label is flux, and becomes flux density, and like unit is flux density simply, and radius. Okay, so this becomes your title, and this becomes your radial flux profile. So this way you can draw your radial flux profile of a star, galaxy, or any object whom you want to study. You can also change the position, and so basically you want to change the center. Okay, suppose you want to go for this object, so change the center and give your center equal to, and then you can give your center here, like center you can give here of that object, and it will plot your radial profile flux according to the center of that object and corresponding aperture. You can also increase the aperture, number of apertures if you want. So from here we have seen that we have only 20 apertures, so you can go for more than that if you want. So I hope you got the idea that how to plot radial flux profile of a star galaxy using Photutils Python coding. This is the code of that. This is the formula we have used to plot. So thank you.